We'll see how far we get. Okay. All right, so on this one, we're still looking at reflections. We are reflecting in the line y equals x, and this is what we are going to do with our points. So we have flipped the x and the y coordinates, so we're going to start by writing out our coordinates, which are the same as the first two problems that we did. So we should still have -1, 2, 3, 4, and 2, 2. Okay, so that is x, y. All right, so what we're going to do is we're going to take those points and we are going to flip them under this line right here. So if I'm just flipping x and y, what would my new point be?
2, -1.
Okay?
3, 4, 3. 2, 2.
Very good. Okay, so go ahead and plot these points into your grid. Okay, so we have 2, -1, 4, 3, and 2, 2. So it should still have this one of the same points. All right, so make sure that your figure matches and it is the same points here. It should look like mine. Okay, moving down to the bottom. This one is reflecting on the line, in the line y equals -x. So we're going to again flip our coordinates, but now we're going to do the opposite of them. So if it's negative, you're going to turn it into a positive. If it's positive, you're going to turn it into a negative. So again, same thing. You're going to write out the points that you're starting with. And they are the same as the previous problem. So we are going to flip our coordinates and do the opposite. So I'm writing that so you can understand where you're putting your x and your y. Okay, so I should be starting with what number?
-2, +1.
Very good, yes. Okay?
And then -4, -3. -2, 2.
All right, so once you have those, you're going to plot them into your grid. Okay, so we have -2, 1, -4, 1, 2, 3, -3, and -2, -2. Okay, so that's how your figure should look. Okay, does everyone have this down correctly? All right, let's move on to the next page, which is rotations. Okay, so rotations, they're turned at a degree at a fixed point, and they're either going to be turned counterclockwise which is what the CCW stands for. Counterclockwise is going to go backwards, like on a clock, and then clockwise is represented with CW, and it goes the way of a clock. Okay, so if you look at the grid, you can see the different degrees. Okay, a full circle is 360, so that's where 360 is. Half of a circle would be 180, so that's what it's going by. Okay, So there's different ways to plot based on what you're rotating. So on the first example, it's telling me that we are rotating this point 90 degrees clockwise, which is the same as rotating it 270 degrees counterclockwise. So what you do is you take your points and you're going to just do the opposite of the x, and then you're also going to flip the x and the y values. So first thing you need to do is identify your points. So x, y. What is point A?
1, 1.
3, 1?
Yes, sir.
What is point B?
3, 4, 3, 4.
Okay, and C?
1, 1.
Okay, so we have y negative x is what we're going to do with those. So again, you're going to flip them, and the x is going to be negative. So how would I write the first coordinate?
1, negative 3.
Very good. Okay?
And then 4, negative 3. And then 1, negative 1.
Okay, good, awesome. So you are going to now, again, put that into your grid. Okay, so we have 1, negative 3, 4, negative 3, and 1, negative 1. Okay, so it is just turned over 90 degrees. Alright, so that's how your picture should look. You're just plotting these points here. Okay, we got that?
Yes, ma'am.
Alright, moving on to the next problem, which is 180 degrees clockwise or 180 degrees counterclockwise. It's going to be the same counterclockwise or clockwise because, again, they meet in the middle. If xy is rotated 180 degrees clockwise or 180 degrees counterclockwise, then its image is the point negative x, negative y. So your x and your y are going to stay in the same order. You're just going to do the opposite to both of them. So again, your pre-image is going to be what you see on the graph, which is 3, 1, 3, 4, and 1, 1. So you're going to do the opposite of both of those here. So that one's pretty easy because all you're doing is you're putting a negative in front of them. So what's my first point going to be?
Negative 1, negative 1. Oh.
Okay?
Negative 4, 4.
And
Negative 1, negative 1.
all right, again, you are putting those into the grid. Okay, so negative 3, negative 1, negative 3, 1, 2, 3, 4, and then negative 1, negative 1. All right. So that is how your figure should look. Okay, we're moving down to the last rotation example. So 270 degrees clockwise or 90 degrees counterclockwise. And we would do, again, flip your x and y, except now your y is going to be the opposite operation. So start with your pre-image points. Okay, and then you're going to write in negative yx here. So your y is going to come first, but now it's going to be changed. Your symbol is going to be changed. So how am I going to write it? Okay?
Negative 4, 3, and negative 1.
Very good. All right, plot those. Negative 1, 2, 3. Okay, so those are my points. I'm going to connect them. All right, so that's how your image should look on yours. Okay, all right, so we got rotations done. So now we're moving on to the next page, which is dilations. Okay, so again, a dilation is a transformation in which the figure is enlarged or reduced. So if it's enlarged, that means it's made bigger. If it's reduced, it's made smaller. And it stays the same congruency. The only thing that's changing is the size of it. So the scale factor indicates how much the figure will enlarge or reduce. Okay, dilations create similar figures, and all the K represents is what the scale factor is. So you can see what a dilation is. You should be able to understand reduction and enlargement. Okay, so we're going to go ahead and do these examples. It says triangle ABC has vertices A, negative 5, 5, B, negative 5, 10, and C, 10, 0, with K equaling 3. List the new coordinates of the dilated image. All right, so we're going to start by putting in our X and our Y from the pre-image. So that would be
Negative 5, 5.
good.
Negative 5, 10, 10, 0.
Okay, so when it says the scale factor is 3, what does that mean I'm doing? Does anyone know? I mean, the scale factor is 3. Do y'all know what we're doing with the 3? Am I adding it? Am I subtracting it? What do y'all think?
Subtracting.
We are multiplying, okay? So the way that would look is you would multiply both the X and the Y coordinate by 3. Okay, so what's 5 times 3?
15.
So the first coordinate would be negative 15 because you're multiplying negative 5. Okay, and then again 5 times 3 would be 15. That one's going to stay positive because that's a positive coordinate. Then we have negative 5 and 10, so again negative 15. And yes, 30 is correct. Okay, last one we have 10 times 3. 30, and then 0 would remain 0 because any number times 0 is 0. Okay, so again, whatever K is, that's what you're multiplying each number by. So this one does not require graphing, it's just practicing how to do that. Okay, so making sure we have that correct. Moving on to example 2. Alright, so now we are graphing. It says graph triangle ABC with vertices negative 2, 0, 2, 4, and 4, negative 4. Okay, so that we are going to graph this triangle. So before we move on to this factor, let's go ahead and graph this triangle that is being described. So this is point A on the line. Point B would be here. And point C would be here. Okay, so I have my 3 points. You need to connect those lines or those points. Okay, so we should have graphed that. Now it's telling me that the scale factor is 1/2. So I'm going to multiply all of the coordinates by 1/2. Okay, and I'm going to help you do that. So we would write 1/2 x, 1/2 y. Okay, so what's half of 2? 1. Good. So my first point is going to be -1, and then any number times 0 is 0. So 0 is going to stay the same. Okay, so again, I have half of 2 would be 1. This time it's going to be positive because we're starting with a positive number. And then what is half of 4?
2.
Good. Okay, again, half of 4, we would start with 2. And then again, yes, we would just put a negative in front of that because -4. Okay, so we have our 3 new points. We're now plotting that into the grid. Since we're multiplying by a fraction, does that mean my figure is going to get bigger or smaller? Yes, very good. All right. Okay, so point A would be here. Point B would be 1, 2 here. And point C would be here. Okay, so those are my new points. I labeled them and then I connect them. Matthew, come here real quick. You're needed in that room. Okay, so go ahead and connect your points if you have not done that. All right, so you can see these are called similar figures because they are the same figure. It's just either made bigger or smaller. Okay, so I'm moving down to the next example. Last example for dilations. Graph F, G, H with vertices F, G, and H. So we're going to write those in. So we have, again, X, Y, -4, -2, -2, 4, and then -2, -2. Okay, so again, I'm just getting those from the ones that were given at the top. Okay, so once you have those written down, go ahead and graph them. It's going to be different than the one that we did at the top. Okay, there's F and G. Make sure those are correct. And I'm adding an H. Okay, let me connect them. All right, so on this example, it's asking me to dilate the figure with a scale factor of -1/2. So -1/2 x, -1/2 y is what I would write here. Well, okay, so we're flipping the sign. You are correct on the numbers. So half of 4 is what? 2, but instead of negative, we would write positive. And then half of -2 is -1, but we would make that +1. Very good, sir. Okay, so half of 2, sorry. 1, but it would be +1, and then half of 4 is 2, -2. Very good. Okay, last one would give me 1, 1. Both positive numbers on that one. Okay, so go ahead and graph those 3 points. Okay, so we got 2, 1. That's F. 1, negative 2. That's G. And then 1, 1 is here, which is H. Okay, so again, your figure has shrunk because you are multiplying by a fraction. Same thing when you're multiplying by a decimal, your figure will get smaller. Okay, so we got our examples for dilations done here, all 3. So now we are moving to the last part of this, and this will be all for the rest of the day. Okay, so composition of transformations. That means whenever you're combining more than one transformation, like if it asks you to reflect and translate, or asks you to dilate and reflect. So we're just looking at how to do that. So it says triangle TRY is translated XY. So it's giving me the way that it's translated, which is -4, -3. Okay, so you're going to subtract 4 from the X coordinates and subtract 3 from the Y. And then you're going to rotate it 90 degrees counterclockwise. So if I go back to rotations, what am I supposed to do when I'm rotating it 90 degrees counterclockwise? I would look at here, 90 degrees counterclockwise, and then this is what I'm going to do to that figure, which means I'm going to flip the X and the Y, and the Y is going to be negative. So that's where I'm looking when I'm wondering what to do with that. So up here I'm going to write negative Y X let me check that again, hold on. 90 degrees counterclockwise. Okay. All right, and then we're going to translate it based on what it's telling me at the top. Okay. So I'm going to start with my original points, which are, what is point T? Okay. 2, 2. Very good. Okay, so it's going to show you step by step how to do this. Not just, you don't just put your answer. We're going to show the subtraction and then show the flip and then the negative symbol in there. So -1 minus 4 is -5, right? And then 2 minus 3 what's 2 minus 3? Anybody? -1. Okay, 3 minus 4? -1. And then 4 minus 3? 1. Okay, last point would be 2 minus 4. And 2 minus 3? -1. Okay, so now we're going to flip our coordinates and we're going to change the Y symbol. So my Y is going to be now what?
1.
+1, and the X stays the same. Okay, my Y is now going to be -1, and my X stays the same. And then my Y here is going to be +1, and -2 stays the same. Okay, so these are the points that I'm plotting, because this is going to be the after I do both of them, both things to them. Okay, so go ahead and plot these 3 points into your grid. 1, 1, 2, 3, 4, 5. -1, -1. And 1, -2. Okay, so those are my points, and then all you have to do is connect them.
She wanted.
Yes, Joe, right here. You need to go to room 2.
Room 2?
Yes. Okay, go ahead and connect your points.
It's running from Ms. Paul's question.
Okay, so that's how your figure should look. This is showing me a translation and a rotation. Okay, same shape, congruent figure. So I am going to move up to our last example. Alright, so our last example, it says find the new coordinates of LMN when rotated 90 degrees clockwise and then reflected in the x-axis. Okay, so we need to figure out what we're doing here. When I am rotating 90 degrees, if you were doing this by yourself, you would come back and look to see what I need to do when I'm rotating 90 degrees clockwise. It's telling me that I need to flip the x and the y, and the x turns negative. So we would write y negative x on there. And then when I reflect, this kind of gets confusing, so you have to make sure you're understanding here. So when I reflect, I would come back to my notes here. I'm reflecting in the x-axis, which would be at the top right here, reflecting in the x-axis. So that means I'm going to go back and do x negative y. So I'm going to show you how that works. Okay, and then up here we have x, y. Okay, so that's showing me the steps. I'm going to start by plotting this point right here, which is 3, 1. I'm going to plot negative 1, 6, and then I'm going to plot negative 3 and 2. So go ahead and plot those points first, and then we'll get into how we're changing this around. So 3, 1 is point L. Negative 1, 6 is M, and then 3, negative 3, 2 is point N. Oh, I did that wrong. This should be 1, 2, 3, 4, 5, 6. Sorry, this is point M. I'll write out that bottom part. My mistake. Disregard that point. Okay, so go ahead and connect your points for the first figure. Okay, so we have our triangle LMN. Okay, so we're going to finish this up. Last thing here, we're going to first flip our coordinates, and the x is now going to be negative. So that means I would write 1 and then negative 3, right? Because you're flipping them and then you're making the x negative. What would the next ordered pair be? 6, 1. You would take the negative off? Yes. And then 2, positive 3. Okay, so flipping them and then doing the opposite symbol. Alright, so on the next one, you're keeping it the same, except now you're changing the y. Okay, so xy stays the same, except now the y is going to be the opposite. So what's the opposite of negative 3? Positive 3. The opposite of positive 1? Negative 1. And then the opposite of 3. Okay, so x and y stay in the same order. You're just making the y the opposite of what it is. So that's going to be your last thing. You're going to write those down, and you're going to plot those into your graph. Okay, so we got 1, 1, 2, 3. Which is L. 6, negative 1, which is M. And N is going to be 2, negative 3. Okay, once you have those, connect your points, and you may glue this into page 19 and then you can start cleaning up because it is time to go.